Lesson 7, exponents as repeated multiplication. So we've used exponents a little bit so far, but they will become pretty important as we continue our studies in algebra. So in the next few lessons, we're going to work with some basics with exponents, so some basic rules. Recall that an exponent is a way to indicate repeated multiplication by the same number. So that's the gist of it right there. So exponents as repeated multiplication. So here's the fancy math definition. It says, by definition, if n is a positive integer, so 1, 2, 3, so no fractions, then x raised to the n power is equal to x times itself n number of times. So now let's look at some specifics with this rule. It says, write out what each of the following exponent means as an extended product. So product just means that multiplication. So what does 2 to the 4th really mean? It means 2 times itself 4 times. Okay, or 3 squared means 3 times itself 2 times. Or 5 to the 3rd, 5 times itself 3 times. That's what it means by an extended product. Okay? So of course, just as with numbers, variables come into play. So we think about that's what makes something algebra. We throw some letters in there. It says, write out what each of the following terms involving exponent means as an extended product. And it says, carefully consider your order of operations. That always seems to come back to haunt us. And remember that exponents come before multiplication, okay? That E in PEMDAS comes before the M in multiplication. So what does, I'm going to have you do what x to the 3rd means. X squared times y to the 4th means x times y 4 times. Now what about letter C? So this means 2x is in parentheses and that's being squared. So that means 2x times itself. So now taking a look at letter D, so we have 4 times x times itself 4 times and y times itself 3 times. So I'm going to let you do letter E, and I'm going to demo letter F. So this is all in parentheses. So this means negative 4x to the 3rd 2 times, but then we could expand that out even further and sort of organize it a little bit differently. So I'm going to put the negative 4's there, and then this is x to the 3rd, so this means x, whoops, 3 times, my parentheses got a little messy there, and another x 3 times. So I just organized it a little bit differently. I just used the commutative property there to rewrite that. So it says, one of the nice aspects of exponents is that they follow very predictable patterns, often known as exponent rules. And they do rule. Haha, this guy's got quite a sense of humor. Anywho, it says, let's figure out the simplest one in the next exercise. So it says, write each of the following products and then express it as x to the n. So what does this mean? This means x times itself twice and then x times itself 3 more times. So really, if we were to express this as x to the n, meaning one base with one exponent, how many x's do we have here? Well, we have 5. And then I'm going to let you do B. And then I'm going to jump right down and tell you that that is x to the 8th. And I bet if you sit and think about that, you'll know how I got that, because now on the back side, we're going to look at that first rule. And it says, so what's the pattern? Can you give a generic rule for what happens when you multiply 2 terms of the same base? Now this is key here. The same base. That is an absolute key piece of information. Notice this is x to the a times x to the b. They both have a base of x, and their exponents are different. So the base has to be the same, and then when you're multiplying, what do you do with exponents? You add them. Okay, so that is a huge rule. So highlight that. Do whatever you got to do to put that in your brain. If you want to start making some index cards, that's a great thing to put on an index card that you could study. Okay, because this is something that we're going to have to internalize. This rule means it's going to have to become very automatic and very quick, so you're going to have some great fluency with it. So with this one, we've got like bases, so, and where it's multiplication, so this becomes x to the 4 plus 9, which is x to the 13th. I'm going to let you do b, and then this one becomes y. They're both like bases, they're both y's, y to the 2 plus 6, which is then y to the 8th. So it says often you will need to be able to multiply more complicated terms and write them in as convenient or simplest, okay, form as possible. This next exercise walks us through how to do this with this expression that's a little bit more complicated. So it says write in what step justifies, write in what justifies each step. So here's the problem, and then all of a sudden we switched around the order. So what allows us to switch the order of multiplication? I mentioned it earlier in the video, and that is the commutative property of multiplication. To switch the order. And now, so what happens here if you follow this? This has just gotten rewritten down here. Now, how did the left side all of a sudden then change to this right side? So all of a sudden now we have got some grouping symbols here. We haven't changed the order from the left to the right, but we changed the groups. And what changes the groups? What property? That's the associative property of multiplication. And then this last one down here, remember this goes to here, so we haven't changed anything, but now how does the left side change to the right side? What's been changed? 5 times 2 has become 10. Okay, that's just multiplication. But now x to the 3rd times x to the 7th has become x to the 10th. Well, that is our exponent rule that we just learned up above. So in the last, so it says each step in an algebraic manipulation, which we just went through, can ultimately be justified using a property. Okay? So, like the commutative property or a pattern, which is our exponent rule. But we also need to become fluent, okay, in these manipulations, meaning they have to be very automatic. So, exercise 7 says rewrite each of the following as equivalent expressions in simplest form. So, I'm going to let you do A, and I'm going to let you do B as well. I'm going to do C. So this means negative 6x to the 3rd times itself twice. So now I can think about this multiplication. So negative 6 times negative 6 is negative 36. Whoops, I lied. It's positive 36. X to the 3rd and x to the 3rd. We have multiplication. The bases are alike. What is our exponent rule? Tells us when the bases are alike, what do we do with those exponents? And hopefully you're saying, Mrs. Swinson, you add them. So this initial problem in simplest form is 36x to the 6th. All right, make sure you do those problems that I left blank, and we'll see you in class.